Hi everyone, welcome. It's video number 26 of the Flip Geometry series. In this video we're talking about the cone, and we've already done the cone, the surface area of the cone in the other set, and now we've been talking about the volume of different 3D shapes. So this is the volume of a cone, and of course the cone has that singular base and that one smooth side that comes all the way up to the single vertex there. Now, like the square pyramid, we're actually going to focus on the height of the cone itself, not the slant height, not what we use for the surface area. For the surface area we looked at the slant height. This is actually referring to the height from the center of the base, the center of this circle, straight up to the top vertex here. So we're going to have to know that, and we're going to have to know the radius, of course, here. So before we get into that, let's take a look, like we did for the square pyramid, at where the formula comes from. The formula comes from the same, similar place as the square pyramid, where if you take three equal cones and take their volumes, so take the volume of this cone, add it to the volume of that cone, and add it to the volume of that cone, that's going to be equal to one cylinder that has an equal base area. So this base area, this base area, this base area is the same as this base area. So this circle, this circle, this circle, and this circle are all the same area. It's just that now this one is a cylinder, so it has the two bases and the space in between. This just has the one. So we know from the formula for the volume of a cylinder that it's simply the base area multiplied by big H. So for this, we're doing the same type of thing as we did for the square pyramid, where the volume of one of these must be exactly a third of the volume of this. So in other words, it's a third of the base area multiplied by our big H. Now, of course, we're dealing with a base area of a circle, so let's put the actual formula together. The base area is going to be pi r squared multiplied by big H. So here we are. This is the formula for the volume of a cone. Now, let's do an example with this cone that I've got over here. Let's say that we have a radius of 3 meters here. And let's say this height here, this big H height, is 6 meters. Okay, so now let's work with our formula here. What I've got is the volume is equal to 1/3 of pi times the radius of 3, which is squared, and then multiplied by big H, which is 6. Now, a fair bit to handle here, but I want to focus on the parentheses first. So I'm simply leaving that 1/3 there, and I'm going to say pi multiplied by 3 squared. Now 3 squared is 3 times 3, of course, so that's 9, and then I've got 6 outside there. Let's start putting some of this together. I can say 9 times 6, so that's 54 times pi. So I've got 1/3 multiplied by pi times 54. Now, what I can say here, I can simplify this further by looking at it as pi times 54 all divided by 3. So, if I take 54 and I divide it by 3, which way am I going to go here? Maybe I'll go this way just to give myself room like I had to do before. So if I've got 54 times pi divided by 3, I can divide 54 by 3, because essentially I can divide 3 by 3 to get 1, and 54 gets divided by 3, and I end up with 18. Okay? So in the end, if I bring this over here, I get that the volume is going to be pi multiplied by 18. So now what I can do, one of two things. I can either use a calculator to calculate pi, a more exact version of pi. Maybe I'll do that first this time since it's in my hand. Let's see here. 18 multiplied by pi gives me an answer of 56.54. So I'll write that here. So the volume is 56.5, is that the rounded version? Sorry, 0.55 would be the rounded version here. And that's going to be meters cubed, of course. So that's our calculator version here for the volume of this cone. Now, if I was to do a non-calculator version, I would have to say 18 multiplied by pi. So over on the side here, I would use 3.14, and I would multiply it by 18. So that's going to be 32, that's going to be 11, and that's going to be 25. And of course, this is going to be 314. Added up, I've got 2, 5, 6, 5, and 2 places of decimal. So I'm getting 56.52, very, very close to my result here from the calculator. So my hand version that I did over here with just 3.14 gives me that the volume is going to be 56.52, and of course it's still meters cubed. So both of these results work if you're calculating it by hand, or if you're calculating it with a calculator, you get a slightly more accurate result. You can see they are very close because the 18 is a small number, so we're getting the same at the first place of decimal, but not the same at the second place of decimal. So there we are, the formula for the volume of a cone.